All right, ninth graders, today you're going to be doing a worksheet dealing with the law of conservation of energy. And so I have a situation here, and this is sort of familiar to something that you may have seen in the notes. And it's basically a picture of a roller coaster or maybe like a Hot Wheels car track setup. So we've got a ball sitting up on top of this curve, and it's going to come down. It's going to do a loop-the-loop around here, and then it's going to go over a little bump and come back this way. And what we want to figure out are what are the different energies at the different places along the way. So position 1 starts out, we're at a height of 4 meters, and the mass of this ball is 10 kilograms. Now, the other things that we look at here, we've got PE, potential energy, KE is kinetic energy, ME is mechanical energy, which is, again, the sum of the PE and the KE. And that is, according to the law of conservation of energy, something that will never change. So once we know the mechanical energy here, we can fill it in for all the positions. All right. The other thing we know that at the very top, there is no velocity. It's not moving right now. So once it starts moving, it's going to obviously get faster and faster as it rolls down the hill. It's going to hit this loop. It's going to come around, slow down a little bit, speed up again, be going its fastest here at the bottom, slow down a little bit, and then speed up again. All right, so we want to figure out PE, KE, and ME. Well, the first thing we can do really easily without doing any math is if we know that the velocity at the beginning is 0, then we know that the kinetic energy at the beginning is also 0 joules. Because kinetic energy is the energy of motion, and if there's no motion, there's no kinetic energy. So now we have to figure out the potential energy. And if you think back to the other day, you practiced finding the potential energy of different things. And so we have a mass of 10 kilograms. G is always 9.8 meters per second per second. And H is 4 meters. So I go 10 times 9.8 times 4, and that equals 392 joules. All right, so I'm going to write that in right here, 392 joules. All right, well, 392 plus 0 is 392 for the mechanical energy. And like I said, the law of conservation of energy says that you can change energy from one form to another and back again, but the total amount of energy you have cannot change, and that is our mechanical energy here. So that will be the same right here, and right here, and right here. So I'm just going to go ahead and fill in 392, 392, and 392 joules for all of those. All right, so now the next question is, we go to position 2. The ball is right here. And now the ball is only 2 meters high, okay? And it does have motion, so we know that the kinetic energy is not 0. Now here is a sort of simple way to figure out what the potential energy is. If it's only half as high as it was, it will only have half the potential energy. So if the potential energy over here was 392 when it was 4 meters high, what will the potential energy be when it's 2 meters high? Well, half of that. So what's half times 392? That's going to be 196 joules. Okay. Now, to find kinetic energy, we do have an equation for that, and it's 1/2 mv squared. But we don't know the velocity here. So is there another way we can do that? And yes, there is. We can figure out the kinetic energy by knowing that potential plus kinetic. We can find the kinetic energy by knowing that the potential plus kinetic equals the mechanical. Well, we know mechanical energy equals KE plus PE. And I know this. This is 392 KE is just KE right now, and PE is 196 joules. All right, so what plus 196 equals 392? Well, we already figured out that 196 was half of this, so the other half, let's just bring this over here, so it's going to be 392 minus 196 equals 196 joules, and that is our kinetic energy. So I'm going to put in 196 joules right here. All right, so then we go to position 3. Now notice position 3 is on the ground. The height is 0. Well, if you have no height and potential energy is mass times gravity times height, or in this case times 0, we know the potential energy must be 0 as well. All right, now once again, I have 392 joules of mechanical energy, and if none of it is coming from potential energy, then it all must be coming from kinetic energy. So just by logic, we can figure out that all of the energy has transferred or transformed into kinetic energy. Now, it starts to go up the hill, and it goes to a height of 1 meter. So now we need to know how do we figure out potential energy and kinetic energy again. There are a few different ways you can do this one. Again, you can say that since we're 1/4 the original height, we would have 1/4 of the potential energy. Or if you want to, just go ahead and mathematically do it again. So PE equals mgh, and we go 10 kilograms times 9.8 meters per second times 1 meter, and that's going to be 98 joules, all right, which is 1/4 of 392. So either way works. 98 joules. All right, so the rest of it must be made up by kinetic energy. So once again, the kinetic energy here will equal my total, my mechanical energy minus my whatever my potential energy is, and that's going to be 392 joules minus 98 joules, and what's that going to be? 294 joules. So my kinetic energy now is 294 joules. All right, so today what you're going to be doing is you are going to practice some of these techniques that I just showed you, and we're going to look at 4 different situations. The first one will be you've got a rock sitting on top of a cliff. The cliff is 8 meters high, and what is the potential energy at the beginning? I actually give you the potential energy, so you don't even have to calculate that. But you know that it's not moving, so what's the kinetic energy? What's the total mechanical energy? And then at those 2 other positions, figure out those same things. And I do give you the heights at those 2 other positions. The second one would be a ball rolling down a hill. Very similar, it's just not falling, now it's rolling, but we start out at 1 height, we go to another height, we finish at a 3rd height, and I give you those 3 heights. This time I give you the kinetic energy at the very end, and you should be able to figure out what the potential energy is, and then what the mechanical energy is, and then know what the mechanical energy is here, what the mechanical energy is here, and figure out the rest as you go. This is all sort of logic work. And then the third one will be a pendulum swinging back and forth. And here I've got the highest point on the pendulum, the lowest point on the pendulum, and then a point that's kind of halfway up a swing. And again, I give you the 3 heights. I give you what the total mechanical energy is here at the bottom. And then you have to, so then what you know what the potential energy has to be when the height is 0, and therefore you'll have to figure out what the kinetic energy is. And then we keep going down here, and then finally at number 4, you throw a ball straight up in the air and it comes back down. You start with a velocity of 40 meters per second and a height of 0. So this time I'm actually going to have you calculate what that kinetic energy is at the very beginning. What is the potential energy when at the very beginning when the height is 0, and then the rest of it is very similar to what you see here. And again, you'll need the mass to calculate the kinetic energy, and the mass is given to you at the beginning of that problem.